So now we're up to page 489 in the workbook. And what we're going to do now is we're going to solve a word problem that involves a differential equation. And so we'll see how we can kind of solve that calculus problem and interpret the results in a way that's going to make sense to the person who's asking us the question. Let me show you what I mean. So we have an evergreen nursery. So this is a place that grows evergreen trees. It usually sells a certain shrub after 6 years of growth and shaping. The growth rate during those 6 years is approximated by the differential equation dH dt is equal to 1.5 t plus 5, where t is the time in years and h is the height in centimeters. We're also told that the seedlings are 12 centimeters tall when planted, which is when t is equal to 0. All right, so the first question they want us to do is they want us to find the value of the differential equation above when t is equal to 3, and then using correct units of measure, explain what this value represents in the context of this problem. In the context of this problem. When you go to college, and especially when you go to graduate school, context is a word that you will use more often than you ever thought possible. Context is just a fancy way of saying that when you're answering the question, you want to be thinking about this other thing and make sure that that has some relevance in your answer. What I mean in this case is that just if I plug t equals 3 into this equation, I get the dH dt is equal to 1.5 times 3 plus 5, which is equal to 4.5 plus 5, which is equal to 9.5. So what that means, what this second part of this question means, is that the person who's running this evergreen nursery, they grow trees for a living. If I go up to you and say dH dt is equal to 9.5, that person's going to say, thanks for nothing. So what does that problem mean? What can I tell this person growing this shrub about the number 9.5 that's going to have some meaning to them? So let's think about what this is. What does dH dt represent? What are we measuring? Remember that dH dt means the change in h, the change in height, with respect to time. So the change in height over time. Okay, so that means that the change in height of the shrub, or we could say the shrub is growing at a rate of 9.5. We need to use the correct units of measure. What do you think the correct unit of measure is for the rate at which a shrub is growing? Once again, there's kind of a hint here in dH dt. We're going to be looking for a rate in terms of height over time. So what's our unit of height and what's our unit of time? And that's going to be the answer to our question. So we're measuring height in centimeters and we're measuring time in years. So it's 9.5 centimeters per year. Is this all we need to say about the problem? Well, we should also use this value of t equals 3 in here as well. So what does t equals 3 represent? Again, in the context of this problem, what is this nursery person thinking about t equals 3? Well, t represents time in years, and a time of 0 is when the seedling was planted. So the change in height of the shrub is 9.5 centimeters per year, 3 years after it was planted. Okay, so now let's take a look at problem B. It says find an equation for h of t. So we know the change in height over time, but we want to know the height of the shrub at any year t. So how are we going to do that? Well, what we're doing is we kind of want to think about how, if we're thinking about how much the shrub is growing at the end of 3 years, we think, okay, well, it's going to be how much is it growing in the first year, and then how much more does it grow in the second year, and then how much more does it grow in the third year. Except it doesn't grow at a constant rate every year. So we kind of have to think about 1 month, then another month, then another month, and for all of those months put together. And we should really break it down more than that. Is what I'm saying starting to sound like what we were doing when we were calculating definite integrals? It absolutely is. And so what we want to do is we want to say that h of t is equal to the indefinite integral of dh dt. Okay, so if we take the antiderivative of the rate of growth, we're going to find the height of the tree, kind of. All right, so the antiderivative of dh dt, the antiderivative of 1.5t plus 5, and we need to add in that term of dt because that's the variable that's changing here. What's the antiderivative of 1.5t plus 5? Same as we've been doing all this time. So it's going to be t squared, and then we need to divide that by 1.5. 1.5 divided by 2 is equal to 0.75. Maybe I'll just write that as 3/4 just to make my life a little easier. Then the antiderivative of 5 is 5t. And then remember, we're taking the indefinite integral, so we have to add our constant term. Okay, so this is interesting. This is close to h of t, except we need to figure out what this constant term is. Can you think about a piece of information in this problem? Pause the video if you need to, and see if you can find the piece of information we haven't used in the problem yet that's going to help us figure out what c is. Well, the fact that we need to know is that the seedlings are 12 centimeters tall when time is equal to 0. So h of 0 is equal to 12. All right, so that means that 3/4 times 0 squared plus 5 times 0 plus c is equal to 12. And so these are both terms are both 0. So c is equal to 12. And so the equation for h of t, the height of the shrubs at any year t, is h of t is equal to 3/4 t squared plus 5t plus 12. All right, and then there's one last part that they asked here. We need to determine how tall the shrubs are when they're sold. How can we figure out what that is? Once again, we want to go back to the statement of the problem. So it sells the shrub after 6 years of growth. So to find out the height when it's sold, we need to calculate h of 6, which is equal to 3/4 times 6 squared plus 5 times 6 plus 12. So 6 squared is 36. Well, maybe I'll do it this way. All right, so clear that out. So 0.75 times 6 squared plus 5 times 6 plus 12 is equal to 69. So the shrub is 69 what? 69 centimeters. That's our unit of height when sold. Okay, so that was a differential equation problem. We needed to figure out what function of h had this first derivative when it was 12 centimeters tall when it was planted, and we needed to figure out the value after 6 years, and we needed to give all of this information to somebody who doesn't know calculus as well as we do. So we needed to take that information and we need to turn it into the context of the problem. So hopefully that kind of opened your mind to the kind of ways that we can use calculus in the real world. In the list of things that I said, these are the things that where people are interested in calculus. Tree growers was not on that list at all. I didn't even think about tree growers. But you can see here a problem where if they can measure the growth of their tree and say, you know what, it's got this linear dependence based on how old it is, there we go. We can turn that into an equation and do these calculations for them. In the next video, we're going to take a look at the last two problems, which is going to be an even more common example of where we're going to see real world problems expressed in terms of derivatives and integrals and differential equations.